of the main innovation is smart grid. So their grid integration, especially renewable energy integration to the grid, connecting vehicle to the grid, these are all the important topic. So today's session, our resource person, Dr. Professor Ganesh Trichy, will deliver these areas. So on behalf of all the participants, St. Xavier's Catholic College of Engineering Management, faculty, students, and from all, I extend our sincere welcome to our resource person. Welcome, sir. Also, I welcome all the participants. Thank you for your active participation. Welcome you all to the fourth day FTP session. Welcome. Now I invite Dr. Janani Nisha to introduce the resource person.
A very good morning to all present here. I am here to introduce today's resource person, Dr. G. Saravanan. He has received a graduate degree in Electrical and Electronics Engineering from the University of Madras, Chennai in 2000. The master's degree in Power Electronics and Drives from Bharat University, Tiruchirappalli in 2001. And a PhD degree in Electrical and Electronics Engineering from NIT Trichy, India in 2009. And a postdoc at the Department of Electrical and Computer Engineering, North Carolina State University. From 2001 to 2004, he was a lecturer with the Noor Islam College of Engineering, Margoy. In 2006, he joined the Department of Electrical and Electronics Engineering in Tiruchirappalli, but he is currently working as professor in the department. His research interests include fast controllers, and renewable energy systems. He has a vast teaching and research experience of more than 20 years. He has guided more than 10 PhD scholars. He has more than 80 research publications in indexed journals with total citations of 3,696, H-index 28 and I-index 59. He has completed several sponsored research projects worth around rupees 306 lakhs. Sir, we are delighted and honored with your presence.
I think I will be audible, right? Right. So not be my. Okay, so a very good morning to all. Right. In fact, I heard that today was holiday. Okay, so in spite of that, actually you are being here. Okay, so though actually the title of the course is on hydro and fuel. So I am here actually to take something about PV system. Okay, so why actually you need a power converters for PV system? It looks like a smart grid and all things. So before getting inside to that, I think all are electrical or there are different groups. Is all or electrical or computer science? Okay. Okay. So I think it may be difficult for you to take it, but anyway, let us see that. Okay. So basically, why actually we need a power converters for a PV system and what type of power converters actually will be there. So that's what today actually I am going to give. So a smart grid will have what type of actually power converters. Okay. So before getting inside to that, you would go and purchase a PV panel, right? So panel if you purchase, you would have also purchased a light. Okay. So what's the difference of taking a light and a PV? So a light is of 250 watts. A panel is of 250 watts. Okay. So what's the difference? No, you will be able to see that. You see here whenever they say. To be able to see that they will put watt, one more circuit will be there. It's called watt peak actually. Okay, so it will not be written. They will not give it is a 250 watts panel actually. So there will be another circuit which will be there. You will see here. So WP. So what does it mean? But in a bulb you cannot see that. Bulb it will be written 250 watts. But when I purchase a 250 watt panel, they very clearly say that it is what? 250 watts peak. Okay, what does it mean? It means that what? No, the maximum power it can give is actually 250 watts. It doesn't mean that what? It is able to give 250 watts at any time. Okay, so that's what it means. And they also very specifically say in condition that 1000 watt per meter square and 25 degrees Celsius. Okay, 1000 watt per meter. When the sun shines at a radiation of 1000 watt per meter square, and when the temperature was 25 degrees Celsius, if these two suits, then this particular PV panel what I purchase may able to give me a power of what? 250 watts peak. Okay, so that's what the condition is. So now the question is, okay, what may be the temperature which will be sitting on the panel? Just imagine that what will be the temperature which will be sitting on the panel. Is it 25 degrees Celsius or it is something more than that? Or what order actually the temperature will be there? The temperature will be there. Any idea? What will be the temperature? The PV panel was facing the sun. So it was facing the sun and it was being kept over there. So what will be the temperature which will be sitting on the panel? Is it 25? 25? No, not by 25. Because atmosphere temperature itself is what? Slightly much more than 25 degrees Celsius. So sun is actually hitting it. So approximately it will be in order of what? So what is your imagination? So what may be the temperature actually which will be there in the panel? Yeah, surely more than 30. More than 30. See, our temperature itself is 32 degrees Celsius sometimes, right? 30 or 32 degrees Celsius, right? But what will be the, so continuously we are actually putting a 32 degrees Celsius that is falling in the panel. So what happens? So what will be the temperature? The temperature will be in order of 55 to 60 degrees Celsius. Okay, so the temperature which is on the panel will be in the order of 55 to 60 degrees Celsius. Okay, so what does it mean to me then? Why I am worried about it when the temperature is increasing? So, okay, let the temperature be 55 or 60. So, but how does it now? What makes me to worry? Now, what makes me to worry? Right? What's the problem? Panel resistance may increase. Panel resistance may increase. Okay, so what is the thought process? So okay, so you may not have seen anything about PV panel, but what actually you thought? A PV panel sitting at temperature of 25 degrees Celsius is good, or a PV panel which is sitting at 50 degrees Celsius is better for me? 50, because more heat is good. That's what our thought process was. Am I right or not? So really we will think that okay, good temperature will generate more power. Okay, that's what actually the real thought process of us. But really it is not true. Okay, really it is not true. However, in case of PV, it is actually not true. If the temperature is more, then the power will actually reduces. Okay, the temperature is more, the power will actually reduces like anything. Okay, so 25 degrees Celsius only what I purchased was what? What I purchased was what? 250 watts. So though I purchased a PV panel for 250 watts, I understand that my temperature will be at the order of what? 50 to 60 degrees Celsius. Then my power will not be 250, it will be actually less than that. That's the one case. The another case was, we said that the irradiation which is actually putting on my panel was 1000 watt per meter square. The next question is it 1000 watt per meter square every time in the PV panel? No, sun won't shine every time equally. Okay, the average irradiation which is actually going and sitting inside a PV panel was almost 800 to 850 or 600 to 700 at few places. So you actually have to understand that a 250 watt panel will not always give you 250 watts, right? And the maximum power which the PV panel can give is depends on what? What are the factors which the power, which the PV can give power will depend on who? Largely vary on irradiation and temperature. These are the two factors actually which actually will change the what? Change the characteristics of the PV. Okay, very two important parameters. It is not that the 250 watts is actually the power actually which you try to do. And we don't want any knowledge about it, and we know that the IV curve of this is this. Okay, the characteristics of the PV was, say, for example, the IV characteristics of this is this. And this is the power and voltage characteristics. You see here, this was drawn at 1000 watt per meter square, so it will give a power of 250 watts. Okay, it is giving a maximum power of 250 watts. Okay, but we understand that is the characteristics is same. Is this characteristics is same every time? This characteristics was drawn for what? This characteristics was drawn for what? 1000 watt per meter square and 25 degrees Celsius. But this characteristics will not be fixed one for case of PV, because we know that who controls the what? Sun, nature. So nature controls these two parameters. So depending upon the nature, the characteristics of the PV panel will also change. That's the only one thing which you want to take away from here. The characteristics of the PV panel depends on two parameters, which are what? Irradiation and temperature. Okay, right? So we want to understand that how does actually will change. Okay. So first case was how does irradiation affect the output characteristics? Okay. So in one case this was an irradiation of 600, the other one was 1000. So what do you infer from it? What do you infer from it? When the irradiation was less, what is happening? You see here, current was actually this, almost very linear. Okay, current is actually less, but what has not changed then? What has not changed in in all the three which is same? Yeah, what you said is right. The shape is same. Please understand that very well. Okay, the shape has not changed in any time. So irradiation is not changing the shape of the characteristics. Okay, okay, that's what I understand from here. You see, the shape is same. Whatever may be the case, my shape is actually same. But it has moved in x and y axis. That's the only thing. So the parameter has changed. So what I understand is with respect to irradiation, the power actually changes. Okay, and the voltage reduces. Okay. So next thing is what? This. So here what happened? Here also what happened? Whether the power reduces with respect to increase in temperature is opposite. And temperature increases. The temperature increases, what is happening? You see here, this is 25 degrees Celsius above. This is 25 degrees Celsius. Next is 35, 45, 55. Okay. So the temperature is actually increasing. What is happening? Power is reducing. So at 55 degrees Celsius, you may get only what? Around 220 watts. Okay, around only 220 watts of power. Okay, again here everything is changing the shape. No changes. No, nothing was. Okay, nothing was. Okay, so what is the only takeaway from here is the power output, the maximum power which the PV panel can give to me is decided on two factors. What are the two factors? Irradiation and temperature, and it is decided by who? Next. This is what you understand. Okay. So now I am interested in taking the one. I am interested in take one. Where will be interested? What is your interest? What will be your interest? If you have a PV panel with you, what will be your interest? Huh? You want to take the maximum power from it. You are always interested to tap maximum. But why I am not doing the same thing in a thermal power plant? In a thermal power plant, I am not interested to take my maximum power. But in the same in hydro, I am not interested to take my maximum power. But I am interested to take my maximum power from a PV. Why? In other two cases, sources are controlled by engineers, but here the source was controlled by nature. So when the source is uncontrollable by what? An engineer, we always be interested to what? Have the maximum power from it. So whenever we get, we actually want to take it. Otherwise, we will actually leave it. But whereas in case of a thermal power plant, I am the person who is controlling the feeding of the coal. So I can actually increase the coal or decrease the coal, and I can have the fuel with me if I don't want or want. Here, fuel will go. So my main interest was to take the maximum power from it. Okay, that's why when you talk about MPPT, this MPPT will be only in PV and wind. Okay, so related to this, wherever we are not able to control the source, we need an MPPT unit. Okay, so fine. So now, okay, now let us think that I connected these two persons. So now I know the PV characteristics. I connected a resistance to that. Okay, let us say I connected a resistance to that. So now where do they operate? Who decides where I want to operate? Who decides where I want to operate? I know the characteristics, right? I know the characteristics. I know the PV characteristics, but where do I operate? Who decides where to operate? You understand what I'm saying? So leave it. Now, if I want to know where they will operate, what are things which I want to know? Where do they operate? What are things which I want to know? Temperature I want to know. Okay. Radiation, right? Okay. Say, let us say there are two persons, okay? They are married together. Earlier, before marrying, everyone has some characteristics. They decide themselves. But when we get married, where do you operate? You understand what I'm saying? So where do we actually operate? Simply I'm asking. So when we are tied together, where do we actually operate? The operating point will be what? Very difficult question. See, before marriage, okay, so before marriage, right? Before marriage, I have my characteristics, I decide myself. And no, but my wife will be of a independent one, he will decide his own case. But unfortunately, they two are tied together. The resistive load and the panel was tied together. Now, who decide where to operate? Both decide means it was decided by where they meet together. You understand that? My characteristics has to meet her characteristic at one operating point, and that operating point only they try to operate. Am I right or not? So this same case, in this case also, where do they operate? We want to know the characteristics of the other person. Okay, so I understand the characteristics of what? PV. I know the characteristics of the PV. What is the characteristics of a resistance? What is the characteristics of a resistance? It's very simple, right? What is the characteristics? What is the characteristics of a resistance? Constant? So if I would say what's the characteristics we have drawn? The characteristics is known as what? What characteristics we have drawn? This is what characteristics? I think this is wrong. It's not giving power. This is correct. Okay? What is this characteristics? Voltage and current. VA characteristics of the PV is known to me. Okay, PV is known to me. What is the VA characteristics of a resistance? What is the VA characteristics of a resistance? Yeah, I is equal to V by R. Am I right or not? We can easily find out. Okay, now where do they operate? Where do they operate? There is one point where they both will meet each other. Am I right or not? The characteristics of the resistance will meet the characteristics of the PV. There only they will actually meet. Okay, right? So we'll see that. Okay. So now this is, let us say this is the characteristics of what? This PV. Now how do you draw? Let us assume that RL is what? RL is 5 ohm. Okay, let us RL is 5 ohm. Okay, for understanding, let us say RL is equal to 5 ohm. So can you draw, how does the characteristics will come? How do you draw the characteristics of a 5 ohm resistance? It's not a big question, you can say. So 5 ohm is here, alright, 5 ohm is there. So if I give 10 volts, if I give 10 volts, it will give what? It will give 2 amps. So you make a dot here. Like 20 volt, 20 volt, it will give you 4. 30 volt, 6. And so, I will get it like this. Alright or not? You understand what I'm saying? I will get a line like this. So where do they meet? So where is the operating point? What is the operating point? The operating point is this point. Because the characteristics of the resistance meet the characteristics of the PV and they operate. Now the question is that point is an MPP? Is that point is an MPP? Is not an MPP. Right or not? So please, this point is not an MPP. Whereas the operating point is here. Okay, this was because in 1000 it is 8.14, but it is not at this operating point. Okay, they are not in that operating point. So now my question is, I want to actually shift this point up. What can I do? What can I do? I want this mini point, I want a mini point to be here. So what can I do? Huh? Change the resistance. Okay, change the resistance. Can you tell me what resistance if I put, I can go to the MPP point? What is the value of the resistance which I have to put here? 5 ohm. 5 ohm is actually not catching my MPP. 5 ohm is not catching my MPP because it is quite away from it. But as what resistance if I put, I will get MPP. Huh? Less than 5. Okay, but exact value. You don't know, you draw right. Now I have this, I have put this. So what resistance it will actually go? Will
30.8.
So it will be decided by who? This operating point. In this operating point, we have a point here. Alright, that BMPP and IMPP, BMPP divided by IMPP will be equivalent to one resistance. Am I right or not? That resistance, if I am able to do it, so that means if I am able to adjust this, okay? So if I see here, this, so you see here 13.72 divided by 8.14 with 3.75 ohm, if I try to put over there, then my operating point will sit like this. Am I right or not? Right? Right? I'm now, if my resistance, my load is 3.75, then I am saying that okay, now I am getting my maximum power from the PV. Right? So, but is it that if I fix it at 3.75, I will be able to take maximum load every time? Okay, now what I do, okay, I just find out this value. That means 3.75. I calculate this load. Now, is it guaranteed to me that I am taking maximum load every time? No. Why? Why? Because the characteristics of the other person is varying. You understand? See, this is also varying actually. So it doesn't mean that if I find out 3.75 and put it over there, it will always take the maximum. For example, so the characteristics will change like this. Okay, you see here, characteristics will change like this. Okay, right? This is the characteristics. Suddenly the characteristics will change here. So now if you have a 3.75, okay, this is 3.75. This is 3.75. Now 3.575 will lie here. Is it MPP? Is it not MPP? It is not MPP. Alright or not? See, whereas MVP is where? Whereas MVP is where? Here. But the same 3.75 will not take me the maximum power outputs. Okay. Now what will be the resistance which I want to put it over there? Now tell me what resistance will make me MVP this point. Huh? 20, 27, how you got 27? I don't know. I don't have any number 27 there. Huh? It is 30.65 divided by 6.52. If that resistance was sitting there, okay, then, okay, 4.7, right? 4.7. So now I am able to do it. So what do you understand? What do you understand? If I have a methodology to change the resistance which is sitting across the PV, I would be able to take the maximum power from the PV. Okay, I should find out the methodology to change what? Change the resistance which is acting on the PV. If I would be able to change the equivalent resistance which is sitting on the PV, then I would be able to take what? The maximum power. Am I right or not? Do you agree with me or not? Right? So now the question comes, yeah, who will go and change the resistance? Can I go and sit there and change the resistance? Right? But I'm interested in tape to maximum power. So how do I change my resistance? Who will change the resistance? My load is fixed. My load is fixed. But then how can I vary the resistance and give it to PV? How can I vary it? How can I vary it? Right? How can I vary it? And the MPPT controller. How can I see? For example, if I have a resistance, I think everyone would have studied what? Maybe if electrical engineers, transformer, am I right or not? Transformer, right? Okay, transformer, studied or not? Equivalent circuit, some circuit, and all those things would have done, right? So what actually we will teach students when actually you put some resistance in the primary, how does it look in the secondary? Is it same or different? So depending upon the transformation ratio, the equal resistance which is there in the primary is what? Same. So if I have a fixed resistance, if I have a mechanism to change my what? Change my what? Trans ratio, I will be able to change the resistance. Do you agree with it? Do you understand what I'm saying? Okay, so there is a transformer. Simply I'm saying, there is a transformer. There was a transformer. And you fix the resistance of the secondary side. If you have a mechanism to change the what? Change the what? The trans ratio of the transformer is the equivalent resistance which is in the primary will change or not? Will change or not? Will change? Right? Because what? What is the formula? I don't know the formula. So what is R divided by K squared or R into K squared, I think. Okay, R divided by K squared or R into K squared. But it is a function of what? The trans ratio. So if I change the trans ratio, the resistance will actually change. Right? Alright, that's what I understand. So if I have a fixed resistance, if I change the trans ratio, but we know that transformer doesn't work in DC. Am I right or not? And moving a trans is not that much easier. Am I right or not? Changing the trans ratio is not simple. Okay, but not something that, how can I do it? How can I change my resistance? How can I change my resistance? Which is an equivalent transformer. How can I say this device is a transformer? There is a transformer, right? Transformer does what? How do you define a transformer? It steps up or steps down. Am I right or not? So do you have here the same word somewhere? Which will step up or step down? Huh? all DC to DC converters will do the same. Any DC converter will do the same. So any DC converter which actually will interface these two can do this objective. Alright or not? So it's how. Now, what is transformation ratio in that converter? What is transformation ratio in that converter? Duty ratio. The duty ratio is the transformation ratio. So same, it's the logic is same. If I would able to change my duty, I would able to change what? The resistances which is actually acting on the field. So that's how I would able to change the resistances, electron. Okay, so that's why we need a converter, MPPT converter in between. Why the converter is needed? The converter is needed to what? Extract the maximum power from it. Okay, right? So let us say that now, let us say the converter was a, okay, like this. Okay, maybe. So I think, let us say this is a boost converter. Let us say this is a boost converter. You know these equations. Am I right or not? Right? V naught is V divided by 1 minus D, and I naught is I in into what? I naught is I in into 1 minus D. So can you find out what is B in by I in? B in by I in. Please find out what is B in by I in. Because B in by I in is what? B in I in is Rn. So if I will be able to change my Rn, then I am changing what? The resistance across the field. So if you can find out what is B in by I in using these two equations. So in transformer, what you know is what? What's the famous equation you write? When a transformer is there, V naught I naught is equal to V naught I naught is equal to V in I in. Right or not? Which is the same here. Please try to find out what is V in by I in. What? I think simply seeing and you cannot do it. At least you want to write it. Do it. At least try. V in by I in. So what is V in by I in? So okay, so actually he has to talk with respect to RL and D. RL and D should be there in the equation. Nothing more than that should be there. Remaining all you have to remove. RL and D. So RL should be a function of RL and D. Yeah. So you get this. Okay, you see here RL into 1 minus D the whole square. Okay. So RL is V naught by I naught. V in by I in is 1 minus D square. So V in by I in is what? RL is equal to Rn into 1 minus D square. Right? So what does it conveys to me? Yeah, I got a good equation. But what does this equation conveys me? Okay, equation is good. But what does it conveys me? It is inversely proportional. It's okay now. But what is the other things it conveys me?
Based on the
Yeah, resistance changing based on duty cycle. That's okay. Then that's one thing it is conveying. Then what is it conveying? Okay, what are the boundaries of it? Say, I can change my duty cycle from where to where? 0 to 1. At 0, what is the resistance? When D is equal to 0, what is the resistance? RL. When D is equal to 1, 0. So what does it conveys mean? What does it conveys mean? I can reduce the resistance. Do you understand now? I can reduce the resistance from RL to 0. But if I want more, I can't do it. You understand? This is what the boost converter will do. If I have a resistance, it can actually reduce it. It moves towards the short circuit. So if I have a 5 ohm, what it will do? It can find out any values between 0 to 5. But at the same case, if my MVP, to track my MVP, I need 6 ohm, it is not possible. So though you write any algorithm, whatever may be the algorithm, if you choose RL is equal to what? 5 ohm, and if you are trying to track what? A 6 ohm resistance, it won't track. You understand what I'm saying? So that's the interesting thing part of it. So RL, so this is equivalent to this. Okay, so you see here. So this is equivalent to this. So RL is 1 minus into D square. Okay, so now, okay, so now I have a 5 ohm resistance in the boost converter, right? 5 ohm in the boost converter. 5 ohm is fixed, and a boost converter was there. So now what duty cycle if I do it? I can take maximum. I can take maximum power. You understand? Earlier, I want to move 5 ohm to what? 5 ohm to make to maximum power. Where I move 3.75. So now, if I want to make this 5 ohm to 3.75 ohm, what should be my duty? If I want to make this 5 ohm into a 3.75 ohm, what should be my duty? What should be my duty? So because I know this equation, so I know what should be my I is equal to what? 3.75. R is 5. 1 minus d the whole square. You can find what is d. Rm should be 3.75. RL is 5, and you can find out 1 minus d square. What is d? So what is the answer? 0.134. If the duty cycle is 0.134, you see. So electronically, if I give a duty cycle of 0.134 to my converter will change my 5 ohm equivalent to 3.75 ohm to the PV. So that's how we actually change the duty cycle, and we make the MVP, make the converter to operate at what? MVP, and this is what called MPPT control. So all the thing is you should know how to control what? How to control the duty of the converter. Okay? Right? Fine. So now can you tell me? So please complete this. Let us see that you are able to do it or not. So RL is 8 ohm, RL is 3 ohm, and RL is 12 ohm. These are the characteristics. So whether they will track or they won't track. So here at D is equal to 0. What is the value? D is equal to 1. It will be 0. Here D is equal to 0, it will be 8 ohm. Right now, 0 and 8 ohm. 0 and 8 is between this. What is the R we need? 3.77. So whether it will track or not? Yes. It will track. It will track. So first case it will track. So this is 0, this is 8, so it will track. What about here? This is also tracked. What about here? It is 9.39. Understand? It is a 9.39. So you will only able to vary between 0 to 8. If I want that operating point, I need 9.39. That is not possible by a boost. At this particular condition, if you try 1000 times also, your algorithm will not work. Okay, you should actually know this before trying to work on with any MPPT algorithm. Okay, so you should also understand that. So you want to choose properly. Okay, so this is a case. So in this case alone, actually we won't track. So here also we won't track. So suddenly, for some operating point, most students may come and tell, at this particular operating point it is working. The same algorithm is not working for what? When I put an irradiation of 400, it would work because boost converter is not possible to increase the resistance at any case. Right? Boost converter is not possible at all to increase the resistance at any case. Okay. Right? Move on. So we see here, this is what I told equivalent. So it's just like a transformer. Okay, how actually primary and secondary. You see here, this is where actually it will try to operate. Okay, if you try to draw a line, boost converter try to operate from this point to short circuit points. Okay, you understand or not? I don't know. So if I have another line, I have a line. This is what load resistance. That means RL. It can only reduce the resistance. So the operating point is only what? Left side. Okay, right? We can only move left side. We cannot come down. If I want to come down, I want to what? Anything I am coming down, I want to increase my resistance. That is not possible by what? A boost converter. So you have to carefully choose this one. This RL before doing an algorithm. Okay, so if you want to, then you want to choose RL and then it will operate completely. Okay, fine. So now tell me here. Now buck converter, how does it relate? I won't give even the input and output. Tell me what is the relation between RN and RL in case of. What is the relation between Rn and RL with respect to duty here? So what's the relation here? V0 is D times V in. Okay. V0 is D times V in and I0 is I in by D. Okay. Using that 2 you can find out. So V0 is D times V in. So V0 is D times V in and I0 is what? I in by D. Right? This? Right. So you get this equation. Right? So you will get this equation. Right? Rn is equal to R load divided by D square. So what does it conveys me? The equation is good. But what does this equation conveys me? Inversely proportional, that's okay. But then when D is 1, please understand, when D is 1, it is RL. When D is 0, it is infinite. So what does it mean to me? Here I can increase the resistance like anything. I can increase from RL to infinite. Whereas a boost converter reduces the value from RL to 0. Okay, so it will operate from where? The point of meeting towards the open single point of the P. It will actually move down. That will move left, this will move right. So it's up to you to select what actually you want. Okay, so whether you need a boost converter, whether you need a buck converter, that will actually decided by you. Right? So I think you can actually see that. Okay, so you see it will be like this. So when I have a boost converter, where it will be? It will be from here to here. When I have a buck converter, it will be down. So if I want to track that side, you can actually track using a boost converter. If you want this side, you can actually track this. So that's how it is there. So what is the takeaway from here? How do I decide? Who decides here? Who decides here? The load resistance decide what to choose. But there are some cases where I doesn't know what is RL. Sometimes I doesn't know what is RL. Am I right or not? So there it will be tricky. Sometimes it may not work. Sometimes it may work. Okay. So there's another converter we have. Okay, called buck boost converter. We have a buck boost converter. Interestingly, these are the three converters which will be there. So here, what is I don't want to calculate. I have an answer. Okay. So RL is RL into 1 minus d divided by d the whole square. So what does it come to be? I can change my resistance from 0 to infinite. Am I right or not? Please understand it. See, 0 to, I can vary my to 0 to infinite. So I can operate this in this, I can operate at this. I can operate at open circuit, I can also operate at short circuit. So where do you, that's why you can see in literatures, buck boost converters are the preferred converter for MPPT. Sometimes. So what does it mean? It means that even if it doesn't know what is the value of RL, it will actually track. In other two cases, I should know what is the value of RL, what is the range of RL. These all things are very important for me to decide how to operate. But if it doesn't know the knowledge about what is the value of RL which is getting connected across the MPPT, then MPPT won't track. But in case, if I use buck boost converter, if I use a buck boost type of converter, it doesn't mean that what actually the load was. Independent of whatever meant the load or the value of the load, it will try to what? Track that MPPT. Okay? So you understand that why we need a power converters. Why we need a power converters? In between what? A PV and a load. This is one of the reasons which we need. The another reason was the voltage element. Voltage problem. Okay, it may be a low voltage, but that's another one reason. So we want to actually match these two voltages. So that's how we need a converter. But that's not the only aim of the converter in case of what? A PV system. Okay. So you see here, it will track the whole. Okay. See here, it can be able to do D at 0, it will be here. At D is equal to 1, it will be here. So anywhere in this IV curve, the buck boost converter is able to track the operating point and try to find out what is the maximum power. Okay, right? So now the question is, how do I vary my D in a real condition? How do I vary? Yeah, fine, I understand that if I change my D, I will get what? Variable resistance. But how do I do that? How do I do that? How do I know where to start? Where to stop? Who decides it? Right? How do I know? One thing which I know is what? This, am I right or not? This is the peak. Am I right or not? That's the peak. Am I right or not? So how do I know I'm left side of the peak and right side of the peak? How do I know I'm left side and right side? Yeah. What is happening in left side and what is happening right side? Let's say power increases, voltage this side. Power increases, voltage decreases. Here Here also, power decreases, voltage also decreases. Am I right? You move from here to here. Okay, I will tell you. Move from here to here. When you try to move from here to here, what is happening? Power also decrease, voltage also decrease. Then you are not in the right place. Okay. So that means I will be able to find out this point. Before this point, if I am going trying to go up, I will always see what? My power will increase and voltage will decrease. That's a good sign for me. If that happens, then what I can do? If that is a sign I am getting it, what I can do? I can still increase. I can still increase. Am I right or not? So that's the sign. If I'm getting another sign, what I want to do? If I'm getting anything other than this, what I want to do? See, one way I want to go up, I have to come down, right? I have to decrease my duty. Am I right? I want to decrease my duty. So first thing is you split this. Am I right or not? So my question is, where do you start? Where do you start? Where do you start? First, I want to give something to it, right? First, I want to give something to it. So where I can start? Huh? Where I can start? Can I start it anywhere? Can I start it any place I like? Is there any restriction that if I do that? Okay. Let us say it's a boost converter. It's a boost converter, right? It's a boost converter. No, I have a boost converter. This is increasing a D will move where? Increasing the D will move the curve where? From here to here. You understand what I'm saying? So any increase in D will try to move the operating point from here to this end. Okay. So which is a good point to where will be interesting point you will try to start. No. So simply I am asking, you like to start here, you like to start here, you like to start here, you like to start here. Where do you like to start? You don't know. Okay, let us say you are trying to climb a mountain, hill. But, okay, and you understand that that's very tough process to go up. Where do you like to start? Huh? Downwards? Is it? You like downwards? You think that it's very tough to go up. It will take a lot of time. I have only a minimum time in it. So where do you like to start? You understand what I'm saying? You want to climb a hill. You are interested to climb a hill. Okay, and you understand that it's a very tough job, but somehow you want to climb up. Where do you like? But you want to climb also. I don't like to climb at here, right? I don't like to climb from starting from here. Why? What are the two reasons if I try to climb from here? Two things. One is time, another one is my energy. So I don't like it. Am I right or not? Okay, I don't like it. So where is the good point? Where's a good point? It depends upon the peak. Right? It depends upon the peaks, right? So we can start somewhere here. Anytime. So it depends upon what actually you are trying to track. So I want some duty cycle. So it's all decided by you. So you can start from some duty cycle. Okay. So you start from any duty cycle. Say let us say 0.5 or 0.3 or 0.4. Any duty cycle you start. So then how to find I am here or here? How to find I am here or there? What I want to do now? First I started. Next I want to do what? I started at 1. I give 1 D. So it has 1 point. I find 1 point. Next thing what I want to do? I want to slightly perturb it. I want to see. I want to find out. Okay, small D I want to do it. Then only I know what? The next operating point. If interestingly, my next operating point is what? Increasing P and decreasing V. Then what you want to do? What you can do? You want to go up. Otherwise, come down. This is a simple algorithm. You actually want to make it. So that's called perturb and observe algorithm. Okay, perturb it and observe it. So what I will do, I will start with one D. Next, what will you do? Small d you give, find out delta P and delta V. So what is this? So whether I am in this curve or this curve, who will decide? The delta P and delta V will decide. Okay. So how to easily say I am here, I am here? How to categorically say that I am here, I am here? There both are same sign. Here both are different sign. You understand or not? That's a simple thing. Whether you come down or whether you go up, here you will get what? Different sign. That means the one will be plus and other will be negative. Whereas if you are here, if power decreases, voltage decreases. If power increases, voltage increases. That is a clear indication for you to determine where actually you are. So you want to decide, and if I am here, I know what to do. If I am here, I know what to do. So that's a simple algorithm. And now I know where to stop. Okay, I'm coming here, I'm starting from here, going, and then I meet that point. The moment I got other point, come back. You will actually the Peter algorithm will actually dance over you. Okay, what's the problem of moving in that particular point? Here. You like the Peter algorithm always will what? You will actually find the peak, but then it will move here and there. So what's the problem? Power will be pulsated. There will be oscillation at the top. How to reduce the oscillation? How to reduce the oscillation? See, I'm in a bike, right? Let us say that someone is driving a bike at the peak of the point. What he will do? Rise, leave it. Rise, leave it. So I can be there. Am I right or not? But I want less oscillation than what I want to do. The delta D what we are giving, the delta D, the change in D what you are giving has to be what? Has to be very small. But what is the problem it will do if I reduce my delta D? You understand what I'm saying? If my delta D is very small, what is the other problem it will do? No, just understand. The time it takes to reach will be more. The time it takes to reach the peak is more. If my step is small, when you go up, it will actually reduce the oscillation. That's no problem. But it will take long time to what? Reach it. But how can I achieve both objectives? As an engineer, I always want to do both. So what can I do? No. I want to reach faster, but at the same time, I need less oscillation. So what can I do?
Initially, delta T will be large.
Initially, delta D will be large. That means, so how can I say that I am in initial state? How do I know I am in initial state? Say, you see, if the slope is big, you see here. When I am here, the slope is big. When I reach the peak, the slope is what? Small. When the slope is small, you also give more delta. But when it reaches the slope of small slope, you reduce the what? The delta. So that's how we actually will achieve what? Both faster rate as well as what? The time. So this is called a modified P and algorithm. There are many algorithms you can actually try. Okay? Let's see how. So you see here, I started here. Okay, I started here. Some duty I started. What's the next step I want to do? I got this point. That means I got P and I got D. My microcontroller read these 2 points. P and the D is calculated. What's the next point? Next what I want to do? Increase the, let us say increase. Okay, I got to increase. Reduce is also right. Okay, so I increase it. So I got another point. So it moves up. Okay, when I increase the D, it moves up. What I observe? Change in P is positive. Change in voltage is negative. What does it say to me? If this is the case, try doing it. Okay, try doing it. So I keep on doing like this. Now also say, okay, I'm doing it. Still the same condition, I'm getting it. I try to do other than this. Go up. Okay, so I'm going up. I'm going up. Going up. Now you see, I'm another way around. The moment I get these two, then I have to be careful. The moment I get what? These two are in same side, then what I want to do? What I want to do? Do the opposites. So I will actually come back. So you move here, come back. And this will actually try to oscillate at that operating points. So this is how I will write an algorithm to actually catch that. How do I run my controller or a boost converter? How do I control my boost converter? How do I vary my duty cycle in the boost converter and get it MPPT track? Okay. So this is the conclusion in this particular point. So do you have any questions? Well, I'll make it in this particular session. Right? So what are things which you understand? To summary, what are things which you understand? We understand the power output of the PV is a function of what? Irradiation and the temperature. Right? These are two factors. So if I am able to control my load resistance which is acting on the PV, then I will be able to extract the maximum power. And we find out that there are three methods to change the value of the resistances. By any DC-DC converter will do the job. So one by boost converter, another one was buck converter, another one was buck boost converter. Whereas the one converter changes the resistance from RL to 0, whereas the other changes from RL to infinite, the third case changes from 0 to infinite. Right or not? And there are two sides of PV car. So one is this, and we actually try to operate at this particular part. We understand how to split these two parts and how to make a what? A P and algorithm, a Petab and observe algorithm to write. So this Petab and observe algorithm is common for what? Irrespective of what? Any converter. So in the converter, it will actually you can write it. Whatever converter you write, the algorithm is going to be same. So you can actually write a converter and you can see that whether it is working or not. So if a student is with you, this particular project you can actually give simply. There is no amount, no money, nothing, but you can actually learn. Okay, one PV panel is needed, right? One PV panel and one microcontroller is needed, and just maybe you can do this in 2000 to 3000 rupees. Okay, so you can actually do with some of your students to learn. So actually, what MPPT was. Okay. We'll take a break and next we'll start the next session. Okay. Okay, two persons having different characteristics. So, for example, there is one person who can run 3 meters per second. There is another person who can run 5 meters per second. Right? Do you understand what I'm saying? One can be able to run 5 meters per second, the other one can run 3 meters per second. I have tied them, okay, and asked to run. Okay, so where, at what kilometer per second they will run? Let us say you and your friend are tied together. You are able to run at 5 meters per second, but your friend is able to run at 3 meters per second. Unfortunately, you are tied. Where do they run? Where do you run? 3 meters per second. You understand that? It was the same case here. Understand that one PV is able to give 3 ampere. The other panel is able to give 5 ampere. But then who decides the current in the stream? The less. So what's the problem? That's fine. You understand the story? You answer it. But what's the real problem? So you understand. Very simple question. Now we talk about 2. Now you understand there are 20 panels which are candidate series. One person is not able to run. This is a serious problem. One person is not able to run. What is the problem? Everyone has to run it. The slower person decides what to do. Alright or not? So what is the problem here? So what does it convey to me? So what is the problem? Because he is running slower, though I am able to generate my power, because he is my friend, I am not generating it. There is a huge power loss to do. Because there is a small place, one person is actually in the ship. It's not that the whole thing is in the ship. Am I right or not? Am I right or not? Okay, right? Okay, fine. But anytime you will think that I don't want to run with her and I want to move forward. No, I won't wait. You both are friends. Understand, you both are friends. Is it any time you will think that no, I will run more than you? When will you think? You understand my question? You two are right there, or you two are friends doing something. When do you like to part away from her? Huh? When your efficiency is high. Time and efficiency is better. See, you understand that? I'll tell you in a different way. There is one work. There is one work. Your friends are sharing. You are doing the work. Okay, I understand that there is a capability of you and your capability of your friend is there to do the same task. When do you like your friend to do that?
You can do a lot.
When you can do the task there with him, then that time you don't want to. That means if you are able to complete the task individually, then combined, then at that moment, what will you think is, I don't want that person. You understand or not? Otherwise, you will go ahead, there's no problem. Okay? You understand what I'm saying? Okay, so similar is the case here. So, what's the problem now? Okay, that moment, we will see that later. That moment will make you to think that I want to run more than him. But you and your friend are tied. What's the problem? Someone has made you to run what? Someone has made you to run more than her. More than that person. That is clear. Objective was clear that I am going to run more than that. But in case if I run more than, the capability of the other person who has died with me, what's the problem? What's the problem? Simply, it's not an electrical question or, Huh? Huh? Just simply tell it. Just slowly. Hmm? Huh? What? Untie and go. Yeah, that's another thing. I'll tell you that. What you said is right. What you said is that we have to do that. That's the next thing. But now, what is it? Why I want to untie? That's why I'm coming for that. Why I want to untie? So if I run, what's the problem? If I run, what is the problem? Then I will do the other one. The first thing is, the moment I run, please understand this. The moment I run more than, say, if he is 3.1, he will be low to me. You understand or not? Until that, he is not at all a load to me. The moment I thought in my mind that I run a slight more than here, he will be a load for me. What is called load? What is called load? Load is different, but in electrical, what is load? Electrical, what is load? Load is the resistances which actually produce what? A resistance is there. So what will happen? What will happen? So load is there. And see, until the moment he is a source to me. The moment he is a source to me. Because I run more than that, he becomes a load. Keeping him for load for a continuous time will do what? Huh? That we already done it. But it's the other way around. You are continuously running with your friend. What will happen to your friend? Huh? Yeah, that is clear. He is a load to me. Then what will happen to the load? Huh? No, you come and tell the story itself. What happened to him? He will be actually dragged and he will be killed. Alright, you understand what I am saying? Similar thing happened here. My PV will act as a load to me, get heated, die. You understand? The moment I run more than the other one, the panel 3.1, if I run, this panel try to get heated, and it will try to burn. This phenomena was called hot spots in people. Okay, it will actually create hot spots. That's when it will suicide itself. So you understand that who is getting heated? That's a very, very, very difficult. Who is getting heated here? Who will be heated? The person who is not in the sun is getting heated. The person who is in the shade is getting heated. That's the different thing. Okay, the person who is in the shade will get heated, and it will try to die itself. Okay, am I right? Or it will try to die. That is called hot spots. Am I right or not? So now you want to come to the next one. So now what you want to do? We cannot make it to. The first thing is okay. I can tolerate with my water. Okay, if I have money, I can reduce my power generation. That will reduce only the amount. But this will kill my power plants. This will kill my power plant one by one. Okay, today that person will be there, next another shade. So it will actually kill. So this phenomenon was called hot spot. So now what do you want to do? What do you want to do? Untie it. Untie is not possible. Right? Parallelly. So there is this also, suppose you and your child are going to get inside a bus. They are running and getting inside a bus. Both has to land the bus. What will actually you do? You understand? Bus is there. Bus is going to start. You actually want to catch the bus. You and your child are with you. Huh? You will lift with him, and then you actually will go. Okay, you actually will bypass the line, bypass the thing in the line. You will take it with you, and then you will go. So similar thing we actually will do. The function will happen here. It's called bypass diodes will do. So they will bypass the bypass the line. Now that means it will bypass the line and it will actually try to what? Save this problem. Okay? But then this will do what on me? That's another one. Okay, right? I solved one problem. What problem I solved? So by making it to bypass, what I solved? What are the issues I have? What are the issues I have because of shading? First is reduction in power. That's okay, third. The next is it will kill itself. But making it to bypass will save the suicide, but it will not reduce the what? Reduce the power loss. It will not reduce the power loss at any time. Okay? We will see that now we will end up the story and we will see what actually it was in what? Electricity. Okay, right? Fine. So what I said is this only. There are two people having different characteristics. You understand or not? There are two people having two different characteristics. Right? Okay. So now, which is same in this? Which is the common parameter between these two? If they are connected in series? Which is common? When they are connected in series, speed is same, here same, current is same. Right or not? So if I want to draw at zero current, try to draw a line here. So what will be the voltage? Can I add these two and put a point there? And I can understand or not? Zero. This is 0 ampere. I am drawing a line. I got two voltages. I put over here. Alright or not? Next you see. I got another point. Right? I got another point. So up to this, these points are here. So 6.8. So what is happening after 6.8? Any current, if I try to go more than 6.8, what is happening there? What is happening to the characteristics? See, this is a short circuit current of what? What I said now, 3 meter per second, 5 meter per second. So this is 6.8 is the lowest person. Whereas here 8.14 was the best person. What is happening? The moment I go more than 6.8 to the characteristics, you see these characteristics. The voltage is it? No, you see here, 0 and then still if I go more, what is happening? You see the line and then see here, the moment if I go more than 6.8, less than 6.8, what is the difference? See, more than 6.8 it is negative. You are able to see that or not? Anything more than 6.8 it is negative. Anything less than 6.8 positive. What does it mean to me in the story? From the story, what does it mean to me? Less than 6.8 it is source. Current is negative, so it is low. I'm sorry. Voltage is negative, it is low. You are understanding or not? So in one case, power is positive. That means voltage is also positive, current is also positive. So power is positive. In other case, current is positive and voltage is becoming negative. So it is acting as a load. Okay, so understand that. So anything which I try to move more than 6.8, then I will get trouble. Alright or not? So who is indicating you that I am going more than that person? The voltage. Moment I know that if the voltage across the panel is going negative, it indicates to me what? That I am going more than what it is coming. So what I can do that? So if it is, I know this is negative. So what I can do? I can put simple diode here. I can put a simple diode. The diode automatically conducts when the voltage becomes negative. So that is called bypass diodes. What is that? So we understand that the moment we go more than that, it will become negative. If it becomes negative, if you put a diode over there, it will actually conduct. Okay, right? So now the question comes to you. Okay. Now let us say that I have a diode here. I have a diode here, and now I put a diode here. Now how do the characteristics look? Now who decides the characteristics of the string? See, the moment I put a bypass diode in the picture. Okay, the moment I left, then who decides the characteristics? The only one PV who is the best PV will decide the characteristics. So how do the characteristics come? It will come like this. Right? After this point, the characteristics will be what? This. Am I right or not? Right? Okay. So this will be the case if I do like this without diode. Okay, without diode, this will be the case. But at this particular point, if I put diode, what will happen? It will conduct. Am I right or not? It will try to conduct, and the characteristics will look like this. So now what has changed? Now what has changed? See, this is the characteristic. This came here. At this moment, this diode conducts, so it diode will like this. So what changed? No, you see this diagram answer. What has changed? The shape has changed. That's the very important one. The shape has changed. Right or not? See here. So what is the problem of having shape changes? No. What is the problem of having shapes? That means this shape. So this place, this place. So what is the problem of having this space? Shapes. Yeah, characteristics changing. So because of the characteristics change, what's the problem for me? Huh? If I have two curves like this, so what is the problem? Okay, otherwise I will ask you, what is this place telling you? What is this place? Now there are multiple peaks. You understand or not? Wherever that is getting curved now, wherever this is curved, you will get a peak in the ball. You understand or not? So that's the problem. You see that. You see here. You see here. Here what? Here. Okay, so we have multiple peaks. We solved the problem, but it induced another problem. So what's the problem of having multiple peaks? What's the problem of multiple peaks? Huh? Our oscillation. Duty ratio. What is having multiple peaks are there? What is my problem? No fluctuation. Maximum power point? What's the problem of having multiples? A simple thing, right? See, in a group of silver, there is only one gold. There are 2-3 golds. What is the problem? See, understand that there is a silver there. Only one gold is there. Which will you pick? But there are 3 golds. What's your problem? But what only you want to pick? No, understand it. There is a group of silver. Only one gold is there, and you are asked to pick gold. But at the same time, there are 3 golds are there. What will be the confusion if you want to pick? Who doesn't know which is higher grams? Understand or not? That's your oscillation. So the problem is trying to find out which is the best of them. So the MBPT algorithm, the earlier MBPT algorithm won't work here. This made you to write a lot of optimization algorithms to track the variability. Okay, so what does happen? We have a bypass diode, we solve the problem, but then it introduces another problem inside the system, which makes us to develop different algorithms to try to find out which peak is the best peak. Otherwise, what will happen? If I write a clear door, here itself will stop. I will stop. I don't know. I will think that okay, that goes go and leave it. Because I am only seeing the curve. Okay, I am seeing the curve. Okay, it came down, okay, right, let's go. But then it's not that there is another curve there which is more than that. So the conventional algorithm fails when it has a multiple peaks. Okay, so that's the interesting thing of what? Having what? Study of different types of algorithms. So I hope you understand now what's the problem, right? You see here, this looks like this. Okay, it has multiple peaks. Sometimes you want to track this. Okay, the third point is the highest peak. Sometimes this will be the highest peak. So we don't know which to track and why to track. Right? Fine. Do you have any questions? Right? So do you have any questions on it? Okay. So that's why you can see. No, every panel when you purchase, there will be written bypass diodes will be there. Right? You see here. So what's the problem? You see here, a small leaf sitting in this place will make what? The panel not functioning at all. Okay. So even suppose if you are not properly cleaning, you will under the problem. If they okay, this side only a small place only it is not clean. It is not like that. Even the small place is not clean. It will affect the whole model. That's a problem. Okay. So, but then if I doesn't want that to happen, what can I do? What can I do? Say, suppose I have a small leaf tree here, but I don't want much things to affect. So what can I do? Huh? Your answer is right. So now today's panels, you can see that we have multiple bypass diodes. You understand or not? So you see here, the same leaf sitting here will bypass the whole path. So what's the problem? The whole power will be bypassed. But at the same time, when I have three bypass diodes sitting there, okay, what happened? Only 1/3 of the power will be actually wasted. So that's a function of having a multiple bypass diodes. And then you can extend this question, okay, can I go? Every panel can have one, every cell can have one diode. Am I right or not? It's right or not? You can extend it further and ask the question that every cell can't it have that, I will solve the problem. Am I right or not? Is it okay? No, multiple. We believe it. But the question is, can I have for every cell one diode? Because I am rich. Right. Assume that I am rich. Will you be an engineer? Will you be able to do? That's a question. There are two problems. One is obvious answer is cost. Okay, the obvious answer is cost. Then the question is technically, okay, is it right or not? No. Because every cell is a diode. Every cell is a diode. So we cannot keep one diode across another diode. So it will not bypass. We need series of what? Series of voltages which can actually produce a negative voltage, then only we can able to bypass it. So it's not possible on duets. Though I have rich, I cannot do it. Okay, that's also not possible. On another case, it will be much costly. So someone can ask, instead of 3, can I go 6? Yeah, I can go. So that question will be right, but then the other problem of cost will come into the picture. Okay? Okay? So, to understand the effect of sales, Right? So, to be summarized, so degree is considerably when one or more models in the string. So, right now. So, what problem we have not still solved the problem of what? Which problem I have not solved? It reduces the power, but then I have not solved the problem of reduction in power. Alright, right? Okay. So this actually, I will find out this and then. This actually made to actually have different type of inverters. Okay, so what's the other way of it is this. You see here, this is what the earlier concept. Centralized inverter. Everything will be contained series and power, and one big inverter will be there in the room, and this will actually pop. So what's the problem? What's the problem? If this person is not well, it will affect the entire array. Okay, ma? So what's the best outcome? See, if this person is not good, it will affect the whole person. So if I don't want to do that, what can I do now? What is simple way? Huh? No, don't get into bypass. Right? That anyway will be there. But what can I do? I can do that. See here, it looks like this. Okay, it's centralized inverter. So if anything is problem to this will get shattered. So the whole everything will get shattered and it will go. So instead what I can do? Don't get into bypass analysis. We will come to bypass later. But you see here the big group. So this affects me. This affects him. So what is the first thing you will do? Try to make it separate. That's a concept. Connect string inverter. Every string, make it an inverter. So that's how it goes. Case. Called string inverter. Right? You see here, every string will have an inverter. This is what a new concept is. Every individual string will have an inverter in it. And they will have multiple strings in the same inverter. Okay, so every string will be having an MPPT. Okay, but what is the problem? Who will oppose this? Who will oppose this? Every string having an inverter. Every string having an inverter, what is the problem? Who will oppose it? Engineering goods. But who will oppose? Yeah? Owner. There, okay. Cost is the high. Right? Cost is high. So what can I do? I can try to find out the best solution of it. I can do this. You see here? Okay. Okay, I have a DC-DC converter here, only for strings, and then I can make what? A centralized input. Okay? And today we have still this also have problem, but today we have every inverter is also connected with what? One inverter. Okay, every PV model is connected with one inverter. That particular concept was called microinverters. So today they are ready to sell PV panels as AC. They say it is an AC module. Just they keep it at the back side of the inverter and you can directly plug as you are plugging a mixer or anything. Okay, because it is very small, easy to do it, no need of any space to keep it. Whereas in the case of a centralized inverter, it needs a space, it needs wiring, and many things are there. But because today's inverters of electronics, to be able to see a small pack actually sitting backside of the inverter. So even with what? A single micro inverter, we can actually do the job. Right? So whether it solves the problem of shading? Huh? No, because still shading will occur between the panels. You understand? That's why still whatever algorithm we have learned, everything is useful. Still it comes to a single path. Okay, whatever might be used. Okay, so Paul Automatically, I try to solve using what? A concept of what? Centralized inverter, string inverter, and a what? Microinverter. So all products try to do that. But what is the other way around I can do that? How can I solve? Do I have time? 10 minutes. Right? Okay. So can I solve this? Can I solve the problem in other way around? Okay. Just think about it. So let us say all are 100. All are 100. Okay, all are 100. So I will get 900 watts. Now right or not? Right? So now we say this is steady. Okay, this is steady. So now what are the two options I have? What are the two options I have? Only bypass or take it with you. When I take it with him, I am getting what? 630. Otherwise, I am getting 600. But totally, how much I am able to generate? 8. Now, you understand or not? See, 100, 100, 100, 600 plus what? The 7 into 3 is 210. So it is totally what? 8 I am able to generate. But because I put it in this connection, I will be able to take either what? 630 or 600. And we will like to take what? We will like to take 600. Right? 630 is greater than 600 or not? Always like to get more, right? 630. Okay? Now, right or not? Is it any way that I can, is there any possible that I can get greater? Can I do it? Why two people is? But I want 8 from this. Do you have any idea that okay, if I do this, I will get that? Yeah. What is that? Let's correct answer. Everything is separated, you will get it. Let's call microinverter. But my question is, I have only centralized inverter. Can I able to get 8? You understand or not? That logic is over. Split it. One is what centralized, other one is string and micro. Now, within a centralized inverter, is it possible that I can able to get 8? No. Okay. So understand the situation in a different way. There are 3 groups. Okay, in one group 3 are not working well. Understand? 3 groups, but in one group 3 are not working well. But now what can I do? Everyone put it in one and make it 3. Is it possible that I can take best out of it? And the problem is these 3 works are in sequential nature. That's why all works are holding. You understand what I mean? There are 3 groups working. One group is working good, the group is working very good, but this group is very lazy. But the work has to do sequence. What is the problem? Because of this sequential problem, though this person is able to do well, nothing will happen. So what can I do? Put this one person in there. Do you understand or not? So try to do this. Can I able to get data? Is it right or not? I don't know. Is it right? See here, 100, 100, 7. 100, 100, 7. 100, 100, 7. Can I able to get data? Can I able to get data? So in both the cases, what is safe? What is safe? No. In this case and this case, what is safe? No. Don't get into the electrical. See the figure and answer. The number of panels which are getting shaded are same. Am I right or not? Please see here. Here also 3 panels are shaded. Here also 3 panels are shaded. Am I right or not? There is nothing more than that. In one case, I other case, very interestingly, I was able to get it. Okay. So what? No. Okay. What I have done? Huh? Hmm? See, what I have done? Nothing. Physically, let it be there in the steady place. Electrically reverse. Understand or not? See, yes, it will be here only. But you try to connect this person here, this person here, this person here. Can I able to achieve the target? I'm right or not? Right. Though the shading was there, but now my mismatch loss is how much? 0. I didn't want any costlier micro inverter to do the job. Am I right or not? So if you are able to try to find out a configuration for a given shade, then what? Interestingly, you can actually try to find out. You understand this? Hmm? Right. Any questions on it? See here, these are 3. So assume that these 3 panels are in the same place. Okay, location wise, physically they has to be in the same place. But electrically, where this has to be connected? This has to be connected as the second panel. Here, this has to be connected as the first panel. This has to be connected in the same place. Shade will flow there, shade will be there, but they actually will be electrically dispersed in a different way. I will try to give the interface. Okay, right? So there are interesting papers. You can see a lot of papers on this particular thing to find out the definition of dispersions. Okay, so in fact, no, this was very interesting thing which motivated us to learn. You can see that actually no. See. So, this is another case. Interestingly, the Sudoku puzzle. You can see in our papers. The Sudoku puzzle was in that nature. Sudoku puzzle, you can see 1 to 9 will actually split out like anything. So, you arrange electrically like a Sudoku puzzle, but keep it mechanically like this. So, you put the shade anywhere. You try to put a shade anywhere and see, electrically it will be dispersed. You understand or not? Electrically it will be actually dispersed. So this is how actually we solve the problem of what? Partial shading in this. Right? So this is also same. I don't know I have that. Try. I think it is. You see here, this was a Sudoku puzzle, right or not? So you see the shade was here, but you see electrically they are dispersed. Okay, so arrange the panel. There are a lot of algorithm. I think more than 200, 300 people has followed it. Still, people are finding any algorithm. If you are really interested to work on it, still you will get more papers on it if you want. But we stop it. So this is interesting. A very, very interesting thing which I have seen is that's a very interesting thing. It will do only 1 week. That's the reality. So though this all will see Sudoku puzzle will give thing only 1 week. So it doesn't need any optimization algorithm to solve the problem. Okay? And actually only 1 week, just a pure algorithm will solve the problem of so whatever we are actually thought. Right? Yeah. So for any type, so this is one type of shading I'm saying. So For another technology, any shading you do, it will actually get dispersed. You go in line, you whatever you want, you actually can scrap anywhere. You actually go and do anything on random manner and then see, still it is your, it will actually splits. Okay, though it is not able to give you what? Exactly 0. That means 810 will not be 810. In this case, you can see that. You see here, it is able to do 4162, but no, see here. It is able to do 4083. You understand? It is very near. 4162 and 4083 are okay. But no, without any costlier devices, it is possible. Okay, so for any case, it will be like this. You see, 5045. So I made it. You do it. Right? I think with this, we will. Yeah, should I have any questions? So there may be a question that what will be your thought process? If I say Sudoku, what will be your thought process? It will work only from 9 into 9. Right? But you can see there are Sudoku for this. Right? You can make 3 into 3 Sudoku, 6 into 6 Sudoku. So based on whatever you like, you can actually do it. Right? So based on your applications, still you can actually find out and make the array in such a way that it is able to give you what the maximum. Okay. So with this we end. Okay. So if you have any questions or any clarifications, anything. No, we always want to take no doubt. Mostly we like to take PPP because even 10 marks in one, say, if you go to a plant, you will see 1,000 rupees on balance. If you try to last 10 marks, then it is not. They even today you can see commercial TV numbers, they are not ready to even stop 5 to 15 minutes. Within 5 to minutes, the person has to reach the spot. Like that, they are actually running. Because it will actually trigger them. Everyone has an area, it will actually come on mobile. As soon as there is one fault, the in-charge person will receive a mobile at this particular place. If there, you please go ahead and do that. So, what I said is this string inverter is actually a 250 kilowatt of string inverter, which has 18 independent strings. The 250 kilowatt panel, 250 kilowatt of string inverter has 18 strings. And every one string is a problem. It will indicate to the concerned person. And the concerned person will be there, has to be there in 5 to 10 minutes. If there is a problem, he will remove. At least what he will do is, he will remove one string and make the other one to operate. That's what is good to us. That much is the private concern, okay, they are not making. Because these all are, they are actually running for business. There are two issues. Suppose they got a good amount of business, that means if they have a contract of about 7 rupees or 4 rupees, no problem. Sometimes they have a contract which is very, very low. They have said,
Doubts?
yeah.
No doubts. So, good afternoon. So, even though holiday, many of faculties attending this conference. This FDP, as a resource person, explained very well from the fundamental. Uh, I think everyone clearly understand the concept of PV panel, inverter design. So all the things are essential for integration of renewable energy integration to grid. So very useful and effective session today. All of you attended. So on behalf of all the faculty members and our college, we extend our sincere thanks to Dr. Samarth. Appreciation, a small memento. Okay, now we'll have a group photo and then we will group pledge. എനിക്ക് ഇൻസ്പെക്ഷൻ അറിയില്ല.
எனக்கு பஸ் இருக்குல்ல ஒரு பேருந்து பஸ்
எனக்கு வீடு மாமரை அங்கேயிருந்து 8 மணிக்கு பஸ் இறங்கலாம் சாதாரண ரேட் அது மாத்தாங்க வரது ஒரு அடுத்தது தண்ணியும் இல்லையா அவன் நிறைய நினைப்பாங்க கூடி வருவாங்க. அவர் ரொம்ப சார் ஒன்றாவது கூட வேண்டாம் அதை நம்ம கிளம்புறதுல நிறைய போகிறோம் அங்கே அப்ப யாரு உண்டு மேடம்
இதுதான் நீங்க கூட்ட அவ்வளவு வச்சுங்களா? வாட் இஸ் திஸ் எக்ஸாம்? வாட்
இது எந்த லேப்டாப்? இது ஆன்லைன்லயே போகுதா? ஏன் பஸ்கோ ஆன்லைன்லயே போகுதா? இது ரெக்கார்டா? ஆன்லைன்ல யார் பாப்பா? ஓ ஏன் லேப்டாப் எங்க வைக்கிறது? ஏன் லேப்டாப் எங்க வைக்கணும்?
ஹலோ சார், இந்த இது எங்க லைப்ரரி சரி சார்,